right, so we're going to continue with Chapter 4. This is 129S, and here we are, mapping the application. So we already did the first bit of this last time, and let me go up here. So we're going to pick up here. All right. So if you have user-directed spidering, which I demonstrated last time, where you just browse through the app, go through the pages, and some tool like Burp keeps track of where you went, then of course you can have the human intelligence. You can fill in the forms, log in, and things like that, and you can have enough sense to avoid dangerous functionality. So it's good. There are browser tools that can help you. You can totally see the details of requests and responses within the browser with Chrome Developer Tools. So if you want to go here, you do View, Developer Tools. This is not Chrome, it's Brave, but it's basically a Chrome derivative. And so you have Developer Tools here, and you can see a lot of information about a page. If you go to the Network tab and preserve the log and then load a page, then you'll see all the network requests and responses that loaded this page. And so here it is loading the main page. If you click on that, it's going to show you this is the main request that loaded the 124 page, and it shows you all the things that were loaded from there, and you can go and see the headers. Here's the request URL that was sent and the response. So you get the kind of information you might find from Burp. You can even modify things and resend them somewhat in here. These developer tools keep getting more and more powerful, so you can do quite a lot of the kind of thing you do with Burp, but Burp is the more professional tool, and that's what we're going to use in the class. But you should be aware, you can do quite a lot right in your browser if you turn on developer tools. And by the way, it shows other things like timing. You can see how long it took to load every part of the page, and that's important for performance, where page is taking too long to load, which component is causing the problem. That's the kind of thing you can answer with the tools there. And so here's that, it looks like doing that for Hackathon. It shows a timeline, how long it took to load each component. And so if one of them is slow and irritating your users, you can use developer tools to figure that out. All right. And so you can find, now hidden content, there's a lot of content on websites that's hard to find. And you can try automated testing, manual testing. You might get lucky and find it. Often there are testing or debugging features left. I remember somebody asked me to pen test their website, and when I logged in, it said login 3. And so I just tried login 2 and login 1, and I found the old login pages that were easy to log in. They said, how'd you get in? And I said, well, that's how you get in. You look at it and see if you can guess what old features have been left behind. There might be different categories of user. There usually are anonymous, authenticated administrators. You might be able to find backups of the old versions of files or something, and that might be quite useful, because if you can see the source code, you can often find hard-coded passwords or keys in the source code or other vulnerabilities. The backup archives may contain the snapshot of the whole application. You may be able to find functionality implemented for testing, default functionality left over in the demonstration code in the development platform, old versions of files, that sort of thing. You may find config files that have credentials, source files for source code, comments in source code, or log files. And all these are things that may contain useful information. And then you can use brute force techniques. If you just run a brute forcer that just tries all the common things that you're going to find on a web page, about, abstract, academics, accessibility, there are tools that do this. Burp has a brute forcer, but it's very slow in the free version. They cripple a lot of these. But dir-b is a tool built into Kali Linux. You do dir-b of a website, and it will just try a huge list of the common names of files and folders on the website. This is often the first step in pen testing a website. You just run dir-b and find out what's out there. And it will just try all the common names and usually find what you might want to look at, like some kind of login page and some other interesting pages. This is often your first step in a website pen test. Let's try a Kahoot. There it is. Okay, I'll wait a few more seconds. It's interesting, almost everybody joins in this class. Other classes only half the people join. There's only 18 people online and we got 14 in here, so yeah, you never know. All right. So, all right, what tool shows the timing of the components loading? They're in developer tools. I've never seen them in Burp. They might be in there somewhere, but they're certainly not easy to find. All right. Which tool is ineffective in its free version? That's the Burp brute forcer that would try all different names. Anything that tries more than like 10 or 20 guesses, they slow it down in the free version to irritate you, to make you pay for the pay version, which costs like $300. Although you can get like a 30 or 90-day free trial of it if you want to try it. But the free version has enough to do almost everything. That's all I ever use. All right, how do you find all of a website's hidden content? There's no way to do it, except, I suppose, unless you were to hack into the server and like get root on it, and then you can list all the files on the server. But modern websites are constructed from many servers. You know, these techniques will find a lot of it, but in principle, there's no sure way. If something really had like a 20-character random name right under directory of the 20-character random name, I don't know how you'd ever find it unless you got like a root shell on the server. Anyway. I hope that's enough to uniquely identify you. My grader will do her best. A little more information would make you more sure to get your points. 42 people, I know who they are. SW may not be unique. Anyway, all right. So you can then look for patterns. Like I say here, here's auth, and all the subdirectories start with a capital letter, and one is called forgot password. So if you see one called forgot password, then you try this add password, get password, reset, retrieve, that sort of thing. You just try to see if they have a pattern, and that will help you guess what other content might be there. You might use numbers or dates. If you look in the sources page if you right-click and inspect in a browser, you can see all the files that were used to make it. Look at the include files. You might find comments with names in it. And the other things, if you actually have them, Java applets or ActiveX controls may contain data, although you don't see those that much anymore. Look for temporary files. Macs create this DS store file. Anybody that's copying directories from a Mac, it'll have that. That's a directory index. You see it also on thumb drives and such. When PHP files are edited, it makes an extra copy here. And the same thing's true of Microsoft Office. It makes a temporary file while you're editing it, and sometimes those things are not deleted, and they're left behind, and they contain old versions of the files. And a lot of tools create temporary files. Burp Pro has a content discovery that will brute force things, generate word lists based on names it found, extrapolate names, test for alternative file extensions. You know, it's really pretty smart. It will take all the clues and try to make a big list of possible things to hunt for, and hunt for them. So it sounds great. I've never used it because I'm too cheap to pay for the free version. I've used Skipfish though. Skipfish came from Google, and it was mainly good at finding things. And it was very good at spidering things because, of course, that's Google's main interest, is finding all the files on the web so they can index it. So they had this thing. I haven't used it in a few years, but it was pretty fun a few years ago. You can use search engines, and the cached contents in search engines will often tell you information. The Wayback Machine has old versions of pages, and people that post to forums like Stack Exchange might include URLs. These are all places you might find information about features of a website. Google's advanced search is quite nice. You can specify a site to look in. You can specify a site and then give it a word like login, and now it'll give you every page in this domain that includes the word login, so that should help you find the login pages. You can look for pages that link to this page on other websites. You can look for pages that are related to the target, similar to it, and so on. There are a lot of these. And some web servers will let you list the contents or see raw source code, especially when they're misconfigured, and that can often reveal information that can help you. Nikto and Wikto are tools you use to scan servers for vulnerable files and versions. The scan is really fast, but I've never found anything useful with it. There's an example of Nikto running on my vulnerable hackathon server, and yet it found really boring information, nothing exciting. People say this thing is great. I've never found anything good with it. I think it goes through a relatively small list of vulnerabilities, and I guess none of the sites I work with have got those vulnerabilities. Now, there's also an alternative way. If you have functional paths, you always go to bank.jsp, and then you specify down here what you're doing. This is a transfer funds, confirm transfer from account to account amount. And so that means you have a whole website, but it's all on one URL. And it's just a bunch of parameters that tell you what page you're in, and that's very difficult to explore. The automated explorers can't handle it. You pretty much have to explore that manually, that sort of thing. You can find hidden parameters. Try adding debug equals true, or a variable like test hide source or something. And Burp Intruder does have a feature to try adding all these things to URLs to see if you unlock any hidden content. So when you analyze the application, focus on areas that seem important. The core functionality that does whatever the main purpose of it is of course your main target, because if it's like a banking application, make sure you can see balances, transfer funds, deposit money, withdraw money, whatever it has. Make sure that stuff is working correctly, because of course that has important to the business. And then look at the edges, error messages, administrative functions, redirects to other sites that may have vulnerabilities, and the core security mechanisms are the session maintenance, where it keeps track of how it knows who you are and that you're logged in. Access control, does it really make sure that the people accessing a resource are authorized to access it? As I mentioned many times, most APIs seem to fail. They have unprotected API calls that fail to verify that you in fact logged in with an appropriate account first. In particular, things like user registration, password change, and account recovery from a lost password are often very fruitful places to look for vulnerability. And so you look any place it takes user-supplied input is a possible place where you might be able to inject code or confuse it, and client-side technology like scripts and so on, and cookies. Those are where you're likely to find exploits, and you'll do a lot of these in the projects, which we're going to start later today in the Web Security Academy. And you can look at the server-side technologies with databases and email and other such things, the scripts that are constructing the web page. And you'll do a lot of that in the projects. So here's places you can feed in data: the URL, all the parameters, everything within the body of a post request, all the data you send, the cookies, other things like user agent, referrer, and so on. All these are data that came from the client that goes to the server and gets processed there, and it might be mishandled up there. Then RESTful URLs, like we say, take parameters and just put them in here like they were directories, so it amounts to the same thing. You have request parameters typically go here, like google.com !Q equals duck. That will send a query string up. They often call it a query string, but they often just do it in an non-standard way. They use a semicolon instead of a question mark. They use the URL encode, like the equals and the semicolon. They put it in a directory structure, even something like this, foo equals bar in a directory name. You know, just it's kind of crazy how the web just doesn't seem to have very many standards that anybody enforces. There's just all these different ways to send data up. A thing to be aware of. And then HTTP headers. User agent is used to see what kind of browser you're using, which normally only is important to see if you're using a phone or not. And you might see a different user interface if you change the user agent to a phone. If you're behind a load balancer or a proxy, it may have an X forwarded for header to identify the source, so you might be able to manipulate that to control which of the server cluster you're talking to and inject content. And you might send in data other ways, email coming in from WebDAV, where you put files on a server and they're automatically added to the web page. The IDS might be sniffing traffic, and it might be feeding the results of sniffing into some kind of web app. So you might be able to get in that way. There are exploits where you send in something and it gets logged, and then you execute the log file, and so on. There's any place where data goes into the system is a possible attack vector. And this may seem overwhelming and too confusing, too many options. It'll become clear in the Web Security Academy while you'll practice doing these things one by one. It becomes more clear when you do it in the hands-on. Here, I just want you to get the general overview that there are all these complicated servers running, getting data from all over the place, and that's why web applications are so vulnerable. The attack surface is typically very large. They call it the attack surface, all the ways an attack could come in. And web servers typically have a very large attack surface. So I got another Kahoot. And let's see if there's comments. Oh, I can see there's no comments in the Twitch. Good. All right, my second screen is working. That's the hard part of this course, is at first it seems overwhelming that there are all these terms and technologies to understand, but the hands-on projects help you get some practice and get familiar with the important ones. The web has just grown like a city, with just sprawling things getting patched on, and more roads, and just more and more junk patched on until it's just sort of a big mess of components that don't really go together very well. We had 14 last time. I'll give it another stanza. All right. All right. So what happens when you edit a text file? One with the -1 at the end is commonly created temporarily during the editing. All right, what system may put data sniffed from network packets into a web app? The intrusion detection system does that. It sniffs the packets, and then when it finds things to alert, it sends alerts somewhere, and they may be processed by a web app. So it's a sort of indirect way to sneak attacks in. Use a defense system against them. All right, which header may expose private data from one website to another website? shows the new website where you came from, which exposes your privacy to some extent, especially if the old website was poorly designed and actually put sensitive information in the URL, like your username or password or something. That would be sent to the next website. That's another reason why you should never put sensitive information as a URL parameter. It should be in a post parameter, which would not be in the referrer or in the logs or in the browser favorites. All right, which vulnerability scanner runs on Windows? Ricto is the Windows version of Nicto, and that's the answer. These tools run on Windows, but they're not vulnerability scanners. This is distributed authoring and versioning. It's just a tool to automatically upload files to the server. And BERT is a pen testing tool, but it's not a vuln scanner. It doesn't have an automatic mode that will find the vulnerabilities. All right. So you can identify what kind of server-side technology is in use a variety of ways. The simplest thing is banner grabbing. If you just look at the response from the server, it will often tell you it's running an Apache server and even what version it's using. It is considered to be a poor practice to allow it to put out that information, but that is how default configured web servers act, and a lot of people don't take it away. You can also just use information that you spot from parts of the website. There's a tool called HTTP Recon that will try to figure it out by just looking for a series of clues, series of features of a website that tell you what technology was used to make it. There's a thing called Wappalyzer that's a browser extension, and it will analyze it and just tell you what was used here. Google font, moment.js, PHP, this version, Twitter Bootstrap, and so on. That does the same kind of thing. It fingerprints a website so you know what sort of technology they're using. You can tell by the platform extensions. Microsoft uses ASP or ASPX, Java uses JSP, ColdFusion, PHP, Perl, and so on. The extensions tell you what language was used or what software was used to make it. And often, if you get error messages, the error message will just tell you all kinds of things. Often, this one's not too descriptive, but here's one that's pretty descriptive. Let's see, this one here was a customized error page. And you can tell it's ASP. I know because it has this format with the big red letters and the resource cannot be found. This is the way ASP errors look. It doesn't say ASP, but you can see it's ASPX up there. And here's another one, generic error message created when an unrecognized file extension. This is your browser. This is not from the server. So this does not tell you anything about the server. You can see the file extension mappings in IIS, how different extensions will go and be interpreted different ways. So different libraries may lead to different error messages. A subtlety, here's OpenText. OpenText has URLs that have these commas in them, which is kind of screwy. That's another web technology. Here's some directory names, Java servlets, Oracle files, ColdFusion, Apple Web Objects, Ruby on Rails, the sort of thing you'll find in names of directories. And the session tokens have common names like JSession ID if it's Java, or ASP Session ID if it's Microsoft, and PHP Session ID if it's PHP. Those are the ones I see all the time, and ASP.NET is a bit pretty obvious too. You'll find them in the cookies. And there's third-party components to add things like shopping carts, login, message boards, and people often use the same old thing. I keep seeing vulnerability reports. There's one called Magento, which is a shopping cart people use on websites, and it keeps having vulnerabilities, and thousands of websites use Magento. So here's the general steps to hack in. You find all the places user input goes in, look at the query string format, and find all the other channels that allow you to send data into the app. That's the attack surface. Then look at the banner coming back. and other software identifiers or HTTP print to fingerprint the server, and you'll find out what software they're using and what versions. Then you can just see if those versions have known vulnerabilities and look at the URLs to find clues about other parts of the page to look at. Here, HTTP print seems to be out of date, but there's other alternatives like Nmap, Netcraft, and Shodan and Wapalizer are more modern tools to do the same kind of fingerprinting to tell you what kind of technology was used on the website. And then you look at the session tokens, list of common technology, or unusual names to try to find out what software they're using and what attacks might work. So here you've got something sending me a JSP page with a bunch of parameters. So that's Java service page. And notice it's got order by name. That's a SQL clause. That strongly suggests that some of these parameters are used in SQL. So I might be able to inject SQL injection there. And is expired is 0. That suggests that you could change is expired to 1 and you could find old versions of pages. So you just look at it and try to guess what's going on and what changes might be useful. So here's another one, ASPX, template is new branch, location is default, version is 2.3, edit equals false. That's pretty tempting. You know it's Microsoft ASPX, TPL looks like a template, and it may be vulnerable to path traversal because here's a location, /default. You might be able to change that path to traverse to a different location. You might be able to change the version number. You might be able to turn edit to true. Any of those might reveal useful hidden functionality. Here's a post sending some data up to the server, feedback.php. It's an email from user at this address to email at that address, subject. So it's connecting to an email server and it's got user-controlled content in all fields. So I might be able to use this to send email or inject email headers and send unexpected email. People find these and use them to send spam and such. Here's another one where you've got view at the end. Well, that's obviously a parameter determining what it does. So you might try edit or add, that sort of thing. And you have an ID number here of the media, so you might just try changing this number. It looks like a small number, so probably the lower the numbers mean things. It's not like a 10-digit hash or something, so you can probably find your way to other things. So if you figure out how part of the website works, you can assume that the other parts are consistent, and same code is often reused. So you might be able to, if your SQL injections are being filtered, there's probably a generic filter used all over the website, and you can try injecting elsewhere to deduce what kind of filtering is there. And we'll see a lot of examples of that as we go ahead. If the app obfuscates data, try to find a place where you can enter the obfuscated string and receive the original. You might be able to find the website a way to use its own code to undo the obfuscation. And we'll have examples in the later chapters and projects where you get to see how that works. Error handling is a problem. Some errors give you too much information. And then there's Google Dorks. This is a lot of fun, and I just did it again this morning. You can search in Google for certain kinds of URLs. And the one I just tried right before class was this one, elma.axt. Elma is a logging engine used on servers, and it puts the log in a web accessible page. So if you look for people's Elma pages, you can find it, and all I had to do was make 2 pages of searching here, and I found the CaliforniaStatePortal.gov. This is their public Elma page. This one here, yep, California Careers or something. Here's a whole bunch of information. Here's whole URLs including cookies and stuff like that, logged in errors. So this is the problem. If there's an error, it gets thrown in the error log, and often people misconfigure their servers so the error log is visible on the web, and now you can get somebody's cookie. In fact, you could even send them a link to click on with like an extra apostrophe in it, so when they click it, it will create an error, and then you can go here and get their cookie and log in as them. This stuff should not be public information, and yet it is here at this California career site. And here's one for the Cleveland Orchestra, their Elma page. So they have some website called CoWeb, and here's the error report. Something keeps crashing, putting out a stack trace, and notice there's a session key right there. That may be a way to get in somewhere, and on it goes. A lot of these big things, so that's the sort of thing that shouldn't be public, but it is. And you can find a lot of those with those Google Dorks, that's what they call them, queries that find interesting vulnerable pages. And here's another one I found in the past. I just put an apostrophe up here in the URL or a quote, and now I get a page of crashes. I know it's ASP, or this is Walmart, Careers Walmart, and I just get a whole stack trace coming out. So I learned a lot of information about their web app that it should not be public from their poorly handling errors. So look, see if there's a consistent framework for security or things that were bolted on later. Often extra things bypass the security. And you can tell from a different GUI appearance or different parameters if something was patched in that they bought from another company or made from another developer, and often the external thing is not completely integrated into their security features. So you look for client-side validation, things where they trust code running in the browser, so you can overcome it by just modifying things in burp. Database operations, upload and download are often very valuable. You can often upload like a malicious PHP file and run it. Places where you display user-supplied data, you might find cross-site scripting there, and dynamic redirects. You might be able to find a way to redirect to another website, and that's another vulnerability like cross-site scripting. Social networking, logins are of course important, and session state and multi-stage logins. There can be logic flaws or other flaws in any of these login where it remembers who you are. It's one of these are the top 10 vulnerabilities of web apps. Failure to handle authentication and failure to correctly maintain the session information, so there's a way to impersonate other users. The access controls you can escalate privileges either to another user, that's horizontal, or up to administrator, that's vertical. And there may be unencrypted communications, offsite links may leak out information, so on. And error messages, as we saw, might leak out information more than you should. And if you have native code that's actually compiled, like C code, it might have memory corruption vulnerabilities, like buffer overflows and such. But most commonly, you get in by finding known vulnerabilities in like extensions to their WordPress or something. That's the most common way you get in. So here's an example of a website. And so auth contains authentication functions like forgot password, login, reset password, and so on. So that's a place you might find useful exploitable things. Site stats down here, core site stats contains statistics. There might be some parameters in there that will let you see things. And home contains user content. So you might be able to get into another user's account by playing with URLs you find there. Icons and images are static content. You'll probably find nothing there but just images. Pub is RESTful resources in public things, and it does have pub user 11, 13, 16, so you might be able to find more stuff by just varying that small number. It looks like it's just counting up through small numbers, and so you might find something there. And shop is the online shopping site, and here it is, various books that people are looking at. So all items are handled similarly. You might be able to find some logic flaws there. This is how you use a map to guide you. And right now it probably seems sort of overwhelming and confusing, but when you do the Web Security Academy, it'll become clear, and that's the next thing. Let's do one more Kahoot, and then we'll get to the Web Security Academy, where you practice these things hands-on. It's much easier to understand that way. So what browser extension will identify your web server technologies? Wappleizer. All right. Which file extension would you find on a LAMP server? PHP, this is Linux, Apache, MySQL, and PHP. All right, which name indicates an Oracle server? PLS, I could do it by elimination. This is not Cold Fusion, it's not Rails, and this is Java. Java has applets and servlets, so it must be PLS. All right, and what token name indicates a Microsoft server? That's ASP Active Server Pages, Microsoft's competitor to PHP. All right. Okay. All right. Good. All right. Good. All right, I'm going to stop this recording.